Hi girls, so just going to correct question 13 to 14. So the first one, it says the roots of quadratic equation are x squared plus bx plus c is equal to 0 are 0 and minus 4. Okay. So I'm asked first of all find the sum of the roots. So the sum means to add. So I have 0 plus minus 4. The answer is minus 4. Then I'm asked to find the product of the root. Product means to multiply. So to get the product, I go 0 times minus 4, which is 0, so my product is 0. Part C then says, hence find the value of b and the value of c. So I say x squared minus the sum of the roots, x plus the product of the roots. So I have x squared minus the sum was minus 4, x plus the product was 0 is equal to 0. X squared minus by minus gives me plus, that's plus 4x. So then I have b is equal to 4 and c is equal to 0. Question 13 then, I have the roots of quadratic equation x squared plus px plus q is equal to 0 are minus 4 and 3. By substituting each root into the equation, form two equations in p and q. So I sub in, so my first one x is equal to minus 4 because I was told the roots are minus 4 and 3. So when I sub in minus 4, I have minus 4 to be squared plus p bracket minus 4 plus q is equal to 0. Minus 4 to be squared is 16. Plus p by minus 4 is minus 4p plus q is equal to 0. So I have minus 4p plus q is equal to, I bring the 16 over, it becomes minus 16. That's my first equation. Now I'm going to sub in for when x is equal to 3. So when x is equal to 3, I have 3 to be squared plus p bracket 3 plus q is equal to 0. 3 to be squared is 9 plus 3p plus q is equal to 0. 3p plus q is equal to, I bring over this 9, it becomes minus 9. Now I have two equations, and you should recognise here that that's going to be a simultaneous equation. Okay, so what I have, my two equations are minus 4p plus q is equal to minus 16, 3p plus q is equal to minus 9. Right, so for a simultaneous equation, you need to eliminate either your p or your q. Okay, I'm going to get rid of my q, and to do this, I'm going to change the signs of the top line. So this becomes plus, this becomes minus, this becomes plus. Minus q plus q, that's 0q, they're gone. And 4p plus 3p gives me 7p. So I have 7p is equal to 7. P then is equal to 1. Now I substitute back into one of my original equations. So I'm going to sub back into minus 4p plus q is equal to minus 16. So I have minus 4p, we just found out is 1, plus q is equal to minus 16. Minus 4 plus q is equal to minus 16. Q is equal to minus 16 plus 4. Q is equal to minus 12. Part C of this then says, form a quadratic equation with roots p plus 4 and q plus 6. So I'm after figuring out that p is 1 and q is minus 12. So I'm going to say p plus 4 is equal to 1 plus 4, that's 5. And q plus 6 is equal to minus 12 plus 6, that's equal to minus 6. So the roots they want me to have are 5 and minus 6. So basically x is equal to 5, x is equal to minus 6. So then I'm going to do the root the way that I showed you today. So it's the sum is equal to 5 plus minus 6, that's equal to minus 1. My product then is equal to 5 times minus 6, that's minus 30. Then I have x squared minus the sum plus the product. So I have x squared minus, the sum was minus 1, x plus my product is minus 30. So I have then x squared plus x minus 30 as my final answer. Question 14, I have the roots of a quadratic equation x squared minus mx minus n is equal to 0 are minus 2 and 5. So I say x equals minus 2 and x equals 5. So I get the sum. So the sum is minus 2 plus 5, and that's 3. My product then is minus 2 times 5, and that's minus 10. So then I have x squared minus the sum, x plus the product. So I have x squared minus 3x plus the product, which is minus 10. So I get this here, my equation is x squared minus 3x minus 10 is equal to 0. Then I just write down, they wanted me to find the value of m and n, so I write down the original equation they gave me, and as you can see that these match up and these match up here. So what I have is minus m is equal to minus 3. So that means m is equal to 3. And I have minus n is equal to minus 10. So I have n is equal to 10. The next part, part B, it says, hence find the roots of the equation x squared plus m plus 8x plus 3n minus 2. Right, I'm just after figuring out what the value of m and n are. So I'm going to sub in for those. So I'll have x squared plus 3 plus 8x plus 3 bracket 10 minus 2 is equal to 0. So I have x squared plus 11x plus 28, because that's 30 take 2 gives me 28. Right, I need to then solve that. Okay, so it says find the roots, so I need to solve it, and I'm going to do that using my guide number method. So my guide number is found by multiplying whatever is in front of my x squared by my constant. So in front of that is 1 times 28, so my guide number is 28. I then write down all the factors of 28 that will have a difference of 11. Okay, so I have 1 by 28, 2 by 14, 4 by 7. Okay, so 4 and 7 will give me 11. So I'll write down 4x, 7x. This sign here tells me that both of them are going to be the same. Okay, so they're both going to be either 2 pluses or 2 minuses. And this sign here tells me that I want plus 11x. So I have plus 4x plus 7x. Now I rewrite this. Okay, so instead of having 11x, I'm going to use my 4x and my 7x. So I'll have x squared plus 4x plus 7x plus 28 is equal to 0. Then I factorise this by grouping. So I take out my x and I'm left with x plus 4. Here I'll factorise, take out my common factor, which is 7, and I'm left with x plus 4. Remember, these two brackets have to be the exact same. So I have x plus 4, x plus 7. They're my two factors. So I'll say x plus 4 is equal to 0, x plus 7 is equal to 0, and then I'll have x is equal to minus 4 and x is equal to minus 7 as my roots for that question. Okay, so part C of this question says, show the equation x squared plus bracket m plus 13x plus 3n minus 2 is equal to 0 has integer roots. Okay, so an integer is a positive or negative whole number, and we know our roots are our final answer. Okay, so it's what x is equal to. So really at the end of this, I should get a positive or negative whole number. So I have here x squared plus m is 3 plus 13x plus 3 bracket 10 minus 2 is equal to 0. So I'll have x squared plus 16x plus 28 is equal to 0. So that's my equation. I get my guide number as I did before. So I'll have 1 times 28, which is 28. Then I'll write down my factors of 28. So I'll have 1 times 28, 2 times 14. 2 and 14 will give me 16. So they're going to be here. So I have 2x plus 14x. This sign here tells me that both signs are going to be the same, and I want plus 16, so that's plus 2 plus 14x. I then rewrite this equation using 2x and 14x. So I have x squared plus 2x plus 14x minus or plus 28 is equal to 0. So then I factorise this, take out what they have in common. They have x, and I'm left with x plus 2. Here I factorise it, take it out what they have in common, it's 14, and I'm left with x plus 2 is equal to 0. So I have x plus 14, x plus 2, x plus 14 is equal to 0, x is equal to minus 14, x plus 2 is equal to 0, x is equal to minus 2. So that's the final answer there. And finally, part D then. Right. I have x squared plus px plus 3n minus 2 is equal to 0 has integer roots. Okay, so find 3 possible values for p. Okay, so once again I have x squared plus px plus 28 after I do my substitution in for n. So I'll then do, okay, so same as what I've been doing previously, I'll write down my factors here. So I'll have 1 by 28 and my guide number, and that's 28. I then get the factors of 28. So I have 1 by 28, 2 by 14, 4 by 7. Okay, Right, so what I'll get, because I told you earlier that this here tells me that both signs have to be the same, okay, so both signs are going to be 2 pluses or 2 minuses, and this here tells me that I want a positive. So that means here I'm actually going to add my factors here, or my numbers here. So I have 1 plus 28, that will give me 29, 2 plus 14, that will give me 16, which we already saw earlier, and 4 plus 7, that will give me 11, which we also saw already. So the only one I was really missing is 29, so we should have been able to find 11, 16 or 29 as your final answer.